Today, we're going to uncover a hidden principle of the universe. It's this incredible link that connects the simple machines we can hold in our hands to some of the biggest ideas out there, like how to harvest the power of a star. So let's dive right in.
It really all boils down to this one question. I know, it seems like a ridiculous leap in scale, right? But the amazing thing is the physics underneath it all is exactly the same. And the answer, well, it reveals this fundamental pattern that's woven into the very fabric of our universe.
You know, if you've ever actually used a hand crank generator, maybe for an emergency radio or a flashlight, you know what I'm talking about. You've felt it. It's this tangible physical sensation that's, well, it's almost magical. And that feeling is our very first clue. So let's investigate that strange magic a little bit, because it's not what you'd think. It isn't about friction in the gears or anything mechanical like that. It's an invisible force, one that just seems to appear out of thin air. Okay, check this out. This is where it gets really weird. When the circuit is open, meaning the electricity you're generating has nowhere to go, the crank just spins freely. It's effortless. But the second you close that circuit, letting the power flow, bam, it suddenly feels like something is grabbing onto the rotor. It actually fights back. So where is that resistance coming from? The answer is this really beautiful piece of physics called Lenz's law. What's happening is that the electricity you're creating generates its own magnetic field, and that new field literally pushes back against the motion that created it in the first place. You can think of it as the universe's accounting system. It's enforcing the conservation of energy, making sure you can't get something for nothing. I love this quote because it paints such a perfect picture of what's happening. Even though the wires in the spinning rotor aren't physically touching, they're connected. They're connected by this invisible magnetic link. The electrical part of the circuit is literally grabbing hold of the mechanical part. That's the resistance you feel in your hand. Okay, but wait, this actually just makes the mystery even deeper. Because in a simple generator, one that doesn't have any permanent magnets inside, where does that first magnetic field even come from? How do you bootstrap all that power from what seems to be absolutely nothing? The answer is pretty wild. It all starts with something that's almost undetectable. The iron core inside the generator holds on to this tiny, faint trace of magnetism from the last time it was running. It's called residual magnetism, and this little whisper is the essential seed for everything that's about to happen. And here's how that tiny seed just explodes into power. That tiny residual field creates a minuscule current. But that current, as it flows through the coils, strengthens the magnetic field. And of course, a stronger field induces even more current. It's a positive feedback loop, what engineers call self-excitation, and it spirals up in a fraction of a second, amplifying that tiny whisper of magnetism into kilowatts of usable power. And this is where we get to the ultimate source of that seed. It's not just some leftover magnetic charge. Its true origin is quantum. It all comes from these tiny microscopic regions inside the iron where the spins of individual electrons have all lined up in the same direction. So a quantum scale effect provides the seed for our macro scale power. Just think about that. And once you recognize this pattern, this idea of a tiny quantum seed getting amplified by a larger structure, you start seeing it everywhere. The generator isn't some clever human trick. It's just one example of a fundamental pattern that nature uses all the time. I mean, just look at these examples. A laser starts with a single quantum emission, one photon of light, which then gets amplified by a system of mirrors into a powerful, coherent beam. Superconductors take the quantum pairing of electrons and scale it up until electrical resistance completely vanishes. Even photosynthesis in plants uses quantum effects to transfer energy with almost perfect efficiency. It's the same principle over and over. Amplify a quantum seed. Okay, so this brings up a really important question. If this bridge between the quantum world and our macro world is so powerful, why isn't everything a generator or a laser? Why isn't this effect, way more obvious in our day-to-day lives? Well, the answer has a name. It's called decoherence. You can think of it as the enemy of all things quantum. It's basically just environmental noise. All the heat and random vibrations in the world are constantly scrambling these incredibly delicate quantum states. Most quantum effects are just too fragile, and they get washed out by all this noise before they ever have a chance to be amplified. The generator only works because that quantum-based magnetism in the iron is unusually tough and resistant to this noise. And all of this leads us to what is, for me, the most profound insight of all. We didn't invent this principle. We just discovered a fundamental aspect of the universe, one that operates completely independent of scale.
I mean, how far can this principle really scale? Well, think about the Earth's molten iron core. It's spinning and churning, and it acts as a planetary scale, self-excited dynamo that creates our entire magnetic field. And the sun, and pretty much every other star, they operate on the exact same principle. The physics happening inside that little hand-crank generator is the same physics that powers a star. So what about scaling down? If all you need is a conductor, some relative motion, and a tiny seed of magnetism, well, at some point, you're not really building a machine anymore, are you? You're just describing the basic interaction of charged particles and magnetic fields. You're describing fundamental electrodynamics. So ultimately, that's the big takeaway. The generator isn't really a human invention. It's a discovery. We just happened to stumble upon this universal law at a scale that was convenient for us to build something and use it. It was always there. All right, so now that we've established this incredible scale-free principle, let's have some fun and apply it to a fascinating, really forward-looking idea, harvesting the sun's power in a totally new way. Now, a lot of us have probably heard of the Dyson sphere, right? This giant, rigid shell you'd build around an entire star. But that's a mind-boggling, almost impossible engineering problem. The solar windmill concept flips the script. It reframes it as a physics solution. Instead of trying to contain the star, you just harvest the energy it's already putting out. And the key ingredient is the solar wind. The sun is constantly blasting out this stream of charged particles at incredible speeds. For our purposes, that's basically an electrical current that's already flowing through space. It gives us both the motion and the conductor we need for our generator principle to work its magic. This idea has so many advantages. Instead of one giant, fragile structure, you deploy a swarm of millions of smaller, independent units. There's no single point of failure, you can scale it up gradually over time, and each little unit is basically the inverse of a magnetic sail, a concept for pushing spacecraft. Instead of using a magnetic field to create thrust, it lets the solar wind blow through the field to generate a current. So, all this leaves us with one final thought to chew on. The generator principle was always out there, just waiting for us to figure out the right amplifier. In this case, some coils of wire in an iron core. So the real question is, what other tiny, robust quantum effects are still out there, just waiting for someone to build the right macro-scale amplifier, unlocking phenomena that right now we can't even begin to imagine?